I welcome Dr. Amita Kapoor for this podcast. It gives me an immense pleasure to welcome an author of a book who just frame words, influence people just like me who are just sitting in the room, just typing something as a code. And here I am with you guys presenting you this podcast with Dr. Amita Kapoor, who is an associate professor at University of Delhi, and not just as a teacher. She started her journey just by writing notes, and which led to the passion of writing blogs, which led to the passion of writing books. And I think, probably the person who has seen the growth of deep learning as an industry from the Stone Age, probably the vacuum tube era of the deep learning. So it gives me an immense pleasure to get you all that insights that you need for doing the actual work in the deep learning through Amita Kapoor, ma'am. I welcome ma'am for this podcast, and it's a fanboy moment for me. Thank you so much for giving this podcast to me.
Thank you, Vishwas. It is my pleasure to be here with you, and I do hope that we have
Yeah.
a beautiful time together. Yeah.
Thank you so much, ma'am. Yes, a lot of your podcasts ponder upon your undergraduate, the influence which your PhD had in your life, not just as a person, but it shifted you, just molded you as a scientist. So, how was your days as an undergraduate student? How do you used to spend? And just wanted you to elaborate your journey as an undergraduate student.
Well, I would say, first of all, I was very lucky. We had a very good group of friends. We had 7 friends together. And it was a really, kind of a group where we would study together, discuss, and learn a lot. And it was basically, ours was kind of first few batches of the college, third batch of the college. So most of the teachers were new. Even they did not knew what to teach, how to teach. They were just, fresh out of their masters. So we had, that moment where we could had molded ourselves, learn by self and all that stuff that happened. And I guess having good friends is good. So, the whole day, morning 9 to 5, we used to study, discuss, argue with teachers. That was again one benefit of having young teachers. You can argue with them. You can say, no, you're wrong. And then they will spend hours to prove they are right. And if they are really wrong, they will even agree to that. So that was, real fun.
But how was your journey as a PhD student? You used to say about you used to go to talks in IISc, which was like very far from the place where you stay, during your
Yes.
undergraduate studies. And like, how was that interest of going to the talks, going to the forums, and just listening to the people who have done some research there? Of course, your PhD is nowhere related to the deep learning and a machine learning space which we have seen, but like, how all these interests molded you to become a deep learning engineer?
Okay. What I would say out here is, first of all, happened was basically, when I was doing my undergraduation and we got introduced to the subject of neural networks. So obviously that was one era when I was like, okay, this is the field of study which I want to do. And then, going through Isaac Asimov's novels and everything was part of, growing up before me. And then Star Trek and everything, that was something we were seeing from childhood. So at that instant, at that particular time, it wasn't, you never used to think that I have to do this or I have to do that. It was like, oh, I like this subject. I have to know everything about this subject. So I used to go to whatever possibilities I had, is applying to different places, even, outside Delhi where we can go. Although, yes, at that time, India was not, because at least my parents were not that forward that they will allow me to go from Delhi. But I tried my best that even if I can go to Bangalore and do some internship at some places, that would be great. But the thing is, it was a passion, which was not seeing anything else, no practicality or something. But yes, I wanted to learn about this subject. I wanted to do this subject. And I guess it continued even till my master's, right? So even in the master's, I did my projects in the field of artificial intelligence. And our work was in the area of knowledge representation, which at that time was a big thing. And uh, the work was quite good in terms of research and everything as well. So it went well. The only thing is, after masters, you had kind of reality strike in. everything is done. Now you have to first do the job. You cannot continue with the passion. So I joined the job directly after my master's. And then after some time into the job, I thought, no, I have to do something else. So I joined with the PhD program with full intention of moving it towards optical neural networks, which never materialized because you have to listen to your supervisors. But still, working with the problems, research, and doing that stuff. And then again, I had an experience. Means I got the opportunity to go to Germany, worked there, and both my supervisors, they were perfectionists. Professor Nakshi Kulla Sharma from University of Delhi and Professor Wolfgang Freude from Germany, Institute of Photonics and Quantum Electronics. So it was a really good journey where I learned a lot. I learned especially to question things, which I guess is something very important for any scientist to question and try solving them up. So that was a good journey.
Yeah, because you have been an academician for quite a while now. Of course, you were in a job, you got bored, and you came to the PhD program, and a lot of things happened. But like, what do you feel about the statement or me just saying academicians have more edge over the data scientists who are there working day and night? What's that one thing that actually makes them have the good edge of this mathematics, this process of analyzing the data set and everything? What's that edge that an academician have over a deep learning data scientist or anybody who's working in the industry?
Well, what I would say is right now, having best of both the worlds is the best thing. In the sense, when you are in academics, you have a lot of liberty to explore. Means I can think of trying this experiment, even if I'm not sure whether it will work or not work. So that liberty gives you a great deal of experience. All right. But when you move to industry, like right now, I'm kind of also freelancing with some of the industries. So, but when you move that experience to the industry is dealing up with the real world problems. Right. As a researcher, as an academician, we choose our problems. We choose a problem which we think we are interested in. Like for example, I'm interested in face recognition simply because I do not remember faces. So I choose my problem. But in the industry, that doesn't work. In the industry, what works is this is the real problem. These are the clients who are ready to pay for this problem. So you are working with the real world problems. So that has its own advantage. But the experience that you gain as a academician definitely helps in industry.
True, because having both the sides of the coin is one which gives the value. It's not like one side being the heads, the other side also being the heads. It's a fake coin at the end of the day. It does not have any value. Yes, that's true. I just want to ask you this one question because you have seen computers evolving for a quite a while. Because, of course, when you are doing such an compute intensive task, you see how good is your compute platform doing. Of course, today we have Google Colab, Azure Notebooks. We have some open source tools which are giving us that scalability. Even though if we don't have anything, yes, we have that scalability. How have you seen this architecture, the computer architecture evolving over the years of time? We had HDD drives, we know that we have NVMe drives now, but still we are facing that issue. Okay, we have a good set of data set, but what and also you I just want to ask you, what's that one disruption that we are waiting for this industry to see? Is it that neural network architecture, or is it just the new magical hardware that we just want to see in the world? What's that?
Okay, what I would say is when the neural networks first started, like when I started working with neural networks, we were basically working on 8086 machines. So, yeah, so
Today we
8086.
study as a theoretical subject, and like I'm like, oh my god, it's completely shocking for me. I didn't know this.
Yeah, yeah. So, those machines did not even had 1 GB of hard disk space, hardly few kilobytes of RAM, and making a neural network, a perceptron, a 2 or 3 layer perceptron, that used to be, an achievement. Oh, it is working and it has learning something, right? So from there, today we have reached a stage where you can, train a model on ImageNet overnight. GPUs have done that kind of, great thing. So yes, we have seen a lot of disruption having, but it is not the disruption in terms of the knowledge. The knowledge which was available for neural networks starting in 1960s, it is exactly the same. Architectures have come up, but they are using the same basic principle of gradient descent, right? And yes, there are new architectures like, for example, GAN is there, right? Which are kind of, crossing the limits that we thought were possible with neural networks. But still, if you go back and read the Perceptron book by Rosenblatt, you will see that he did foresee that these things can happen. These things are possible because that showed a possibility. A network which can learn can move to that particular perspective. But today, where we stand, we require an approach where we want to have a multimodal system. So still, when we talk about real-time systems, things are not that fast. Means, GPU is good, but GPU is expensive. You cannot put it up at any place, at every place. So we do require real-time fast sensors, fast processing, and at the same time some sort of an system which can integrate everything. So I presume the IoT and edge can be something, which can give us with some better and some more faster possibilities.
Yeah, ma'am, you told about how just building something which is not that fascinating today, because we also thought like if somebody does dogs and cats in 2017, that was the peak time where blockchain was in the peak, big data was in the peak, and we just saw that new way. Because if somebody does cats and dog classification, yes, he's a god there, because there were very few people who used to spin up some cloud instance, get the model, deploy it to some extent. So today frameworks have been reached to an extent where it's like reusability of the code is just being done in terms of architecture and also in terms of deployment. Yes, we have seen. Like, I just wanted to ask you this one question: what's the influence that an literature and the journalism have on this field today? Because we have seen hardware has had some influence, because we saw that PCIe 5 just came out and it just increased the way in which the hardware was being performed. But like, how has these technologies, let it be something like Twitter just giving out paper or anything, how have these technologies been an influence for quite a while now?
One thing which I would say with this technology, especially social networking with this perspective, like Twitter or Facebook, it has given us a platform to talk and interact. Like, for example, last year I was assistant in Neuromatch. It was an international conference held online. So, that was something which was again not possible few years earlier. To have a platform where thousands of students can interact, you can teach them online at the same time, discuss the problems, do the projects in real time. That was something which was not possible. And how did all that spread is again with the help of the social networking. So we have a good, cohesive groups being formed, that like homophilic groups or cohesive groups, whatever you may like to call it, but you can interact with the people with the same interest. Like, for example, even if you talk about this artificial intelligence, there are some very interesting groups on Facebook, as well as in Twitter. You can follow Hinton, you can follow Individual, you can see what is happening, you can interact with them, comment on their posts, and if you have something useful, you get a comment back, reply back. So that kind of things is something which was not possible earlier. So I would say, in terms of the flow of education and spread of information, these things have done a real good job. At the same time, yes, the flow has affected the fake part as well. So I guess that is, we have to take both the parts. We cannot stop one and have one. That has to be there. Yeah.
Yeah,
So discussion
because
is needed.
yeah,
Yeah.
there is a huge discussion which is happening. There's
True.
disinformation, machine learning, fairness, which are coming up on this subject itself. So let's not touch on it,
Yeah.
because it's a whole new conversation that can
It
happen.
is. It is.
Yes.
True.
I just wanted to ask you this one question, because you have seen neural networks evolve, you have seen algorithms evolve day by day. It's like step by step with a new solution, inch by inch. It's an inch by inch, it's a new solution, step by step, it's a new transformation that we just saw in the when we just read the research papers, or else when we just read the blogs, we just feel so. But what's that influence of having an experience in solving problems and also solving new problems. I just want to ask you in a simple terms, like, is experience in solving problems good enough to solve any problems in the future in terms of machine learning? Because we saw how optimization
And
functions evolved quite a while, and lot of things have happened, but like, how to keep track of it, and is that experience of solving problem really that influential in solving problem today?
problem solving, I would say, is an art, first
Yeah.
thing, and it can be learned, right? Means it's an art, but it can be learned. It's not something that cannot be learned, and it is something, one has to learn. If you learn it at one stage of your life, you can take that knowledge and adapt to any other stage in your life, and not just stage of lives, but also the fields in which you're working. So I guess problem solving is something which is very much necessary, and that is definitely needed. So if you have that capability and you learn to solve how to go about it, that's something really great. And I guess programming does involve that kind of a thing where you are given a problem and you are asked to write down an algorithm of it, right? So if someone learns that steps, means you do not need a language to do that. Even if you know how to do it in terms of words, that is problem solving. You can have a lot of coders, but you cannot have a problem solver available easily.
Yeah, because many people have been decided, because when I joined engineering, I started conducting workshops. Many people just told me, man, I just took MBBS for no reason. People have really told me this, because when I talk with hundreds of people out, and they come to me, they want, but yeah, I just want to get the problem solved. They really feel like, okay, man, I'm not feeling that thrill of working with technology. Of course, probably you have also felt it, because you worked on a problem statement which involves purely on photonics. Of course, you developed your own C program, you also developed a lot and lot of functions for it. But how was the transition back to the learning process of learning neural networks, which is a wholly different world, which was a wholly different shift from the photonics being done by you? Because there are a lot of people who want to shift their career. Recently, I did a podcast with Dr. Rajesh Lal Chandani, who is an amazing dermatologist who is working on the Botox, uh, and everything is going fine. He's a dermatologist, his life is good, but he really wants the thrill of working in AI. So has taken a lot of courses in AI and all these. I just want you to give that tip for those people who want to who want that little transition in their career from what they're doing to the deep learning space.
Okay, in this particular part, I will divide in basically some different components, I would say, right? So there are few people who would like to go for deep research into the field of AI, right? For these people, I will say it's important that you have an undergraduate knowledge of neural networks or artificial intelligence. It is important that you have a strong background of mathematics and probability, statistics, things like that. And it is important that you are well to do with the recent research, coding, and everything. So since I am into AI research, I would say I had all these things available to me because I had studied it at undergraduate level. I had done my research in the field of AI in master's level, right? And then I was also teaching the same paper at undergraduate level. My PhD was totally different for me, rather, because it was in the field of optoelectronics, and I had to, study optics for that, which I had kind of, never thought I will do. So that was more tough for me as compared to going back into neural networks. But still, I have done that part also. So what I would say is, if you are into AI research, you have to have a strong background. You have to develop that strong background. There's no way beyond that. But then there is something. I am in a field, like for example, that the doctor dermatologist that you're talking about, he has an experience, a vast experience in his whole existing field. So for him, going and thinking that, okay, I will develop a new AI architecture may not be that possible or may not be that useful also. But he can definitely think of using the existing AIs, or just knowing that how AI works. He can think of applying it into his dermatology. And that is where new innovations happen. right? So that is another aspect of it. And then we definitely have AI engineers, which are people who are really good at understanding the code and implementing it, right? So we have all possibilities there. It just depends which level you want to go.
Yeah, in one of your podcasts, you also told about not moving ahead of our responsibilities. That's what you said now also. Like he's a
Yeah,
dermatologist, he can use these techniques to improvise on his treatments and
true,
everything.
true, true.
Yeah, and he
Yeah,
also
like,
ponders upon that.
yes, and like what I would say is, even if you go with this, and I guess this is something which most of the people have recognized as well. Like, for example, if you go to the courses, then there are specialized courses for people who want to understand AI so that they can apply it into their domain. And there's no need to change your domain just because AI is working good. AI is just a tool, right? So I do not change whole my everything just to get a tool. I use that tool for work which I'm doing, and if that tool is good for it, why not use it? So AI is just a tool, but if I have an expert experience in something else, I will try and take it there.
Yeah, ma'am. And in one of your podcasts, you also talked about psychohistory. It's
Yeah.
an it's not a typical subject which anybody talks, apart from the people who you think who are working in something as a subject like cognitive sciences, or who are people who are working on a consciousness and everything. What's that subject all about, and how can it be that influence in building an AGI?
Okay, so you see, basically, when we talk about the psychohistory is basically a fictional subject, and it was basically mentioned in Isaac Asimov Foundation novel, Foundation series. So, what happens is basically psychohistory is supposed to be a field of mathematics as per Asimov, and in this mathematics, the statistics, probability, and modeling has been used to a level where we can predict how humanity is going to behave. So if we talk about a group of people, we can say this is how they will behave. So that is the whole foundation series is about, that how this is happening and how they are broken up into different units, so that the system goes on and everything like that. If we see today, we have similar strings. We talk about networks. They can be neural networks. There can be any dynamic networks for that matter. For example, the social networks are totally dynamic networks, right? So how these even neural networks are dynamic networks, because the connections are they are formed and they are removed and they are modified, right? So how these dynamic networks behave, how we can study these dynamic networks, and based on the study of these dynamic networks, we can come up to lot many other understandings, how they organize themselves, who are the important components in that, what are the centrality measures in those particular networks, which particular node can be more important, and just removing that node can create a difference. So things like that are available. So I would say psychohistory, means today we may not call it a psychohistory. Today we have social network analysis, neural networks, and everything to working separately, but they all are pointing to the same direction. And when you take that a step further, probably understanding, AGI probably would be understanding neural networks more as a network of neurons rather than just a gradient descent problem that we are doing right now, right? So something like the cognitive architectures that we talk about. So I guess that may be another step which probably should lead us to AGI.
Are there any resources for this, like any
Lot
book,
many,
papers?
lot many. If you go, you can research about cognitive architectures, clarion architectures. There are lot many books available, and research papers also available. There's a lot of people doing work in the field of AGI. So I think that should be there. But one thing which I would suggest is, which is always interesting, Minds and Machines, Marvin Minsky course. So that's really wonderful. And if you have an interest in consciousness and AGI, and I would say definitely go and attend that one.
I want to ask you this one question, like, what's the most beautiful concept that you have come across in the deep learning? It can be a mathematical, or else it can be something related to the consciousness. There are fallacies which have come out based on the consciousness, it influencing us to. Actually, I recently asked a question whether the deep learning or the AI was being invented or discovered. it was a whole new conversation which is still happening within my group and Bill Schmarzo's team. So yeah, but I just want you to answer this question of what's the most beautiful concept that you have come across in deep learning?
Well, I would say deep learning is still has to make something which is very beautiful. We have something in physics, yes. The Schrodinger equation is my favorite. I love it.
Yeah.
And the photon entanglement, that is another interesting phenomena. And knowing about it, understanding it, and the way it influences everything, especially the field of quantum physics, that is wonderful. Deep learning, I would say, it inspires you more in terms of how, again, as I say, it is a tool, how you can apply it to different parts, right? Means I would say our brain is the best, our brain, our intelligence is the best gift that we have, right? Neural networks still have long way to go and come up to this particular perspective, but probably the concept of blockchains combined with artificial intelligence and quantum computers, we might see an intelligence which we can say, oh yeah, this is some intelligence which you know is kind of equal to ours.
Yeah,
That would be wonderful.
yeah. You are recently working with GANs now, generative adversarial neural networks. So now, when you look at the GANs, of course, neural networks have been a win-win solution for quite a while now. Of course, reinforcement learning is the next step. If you don't get the solution here, just go with the reinforcement learning. But I just want to ask you this one question. Will GANs be the next de facto architecture that we might be working on in the future? Because we have seen lot and lot of applications coming up from GANs, which
I
are,
would say we are already in the GAN phase, and we are
oh,
moving now more towards RL phase now. More and more people are working in the field of reinforcement learning, because that is now kind of new adventurous field. GAN, if you see last few years, more than 50% of the papers are in the area of GAN, right? So I guess the trend is going to move from GANs to probably reinforcement learning now, or combining GANs with reinforcement learning, which is even going to be more wonderful.
yeah. But I just want to ask you this one question: how has the compute platform changed with the intent of making an intelligent machines? Like, how have these concepts influenced the hardware engineers to build something as in compute that we have a
Well, I
requirement
would
for?
say GPUs and everything have become kind of past. Now, what you can see in terms of hardware is development of quantum computers, and that is again something which is uh, pacing up fast now. It's like few years from now, I could not have thought about having a commercial quantum computer possible, but today it is. Even if it is just two qubits, it is there. All right. So that means we will be seeing soon a good amount of quantum computers available to us. Cloud we already have. Quantum computers we do have available from IBM, right? But it is limited. Yeah, definitely it's just 4 qubits and so on. But I guess in the future we will be seeing more and more of quantum computers, and that should pave way to a faster computation, much faster than what we think from GPU, and probably much more innovations that we will be seeing with those competitions.
But what about the benchmarks that we are seeing now? Because we just see 99.99% accurate systems which are coming up. Will they really influence us in the future to build something as good as in human intelligence? Of course, human intelligence can also be flawed sometimes, but how are they going to affect us in the future?
The thing is, even today when we talk about 99%, 9.9% or even 100% accuracy, like I have some students claiming, ma'am, we have achieved 100% accuracy. Even if you have 100% accuracy in a task, that is just one task. A child, even 2 year old, can do a lot better in many tasks. He may not be perfect in one, but he can do average in more than one task, which is not possible right now with our systems. Is even if I talk about RL agents and we say, okay, they can play many games, they're still games. Can the same RL agent which was playing a game cook? What changes will be required? Right. So that is something which is still to be seen. But that doesn't mean it is not possible. We are moving to the place where people are now thinking that, okay, we have to move to this step also now.
Yeah, no, since you have written a lot of books on neural networks and TensorFlow, mostly focusing on TensorFlow, and now you're moving more towards the quantum machine learning part of it, and also
Yeah.
more towards the cloud now. I just want to ask you this one question. Has the game of technology changed as soon as the TensorFlow was open sourced, or else what was it all about? When
What I would say out here is, means like if you have ever tried to build up gradient descent on scratch, from scratch, like implementing the differential equations, updating the weights and everything. So if you had to do that, when there were no deep learning frameworks, we had to start from first understanding the gradient descent at the derivation level, not just in terms of algorithm, but at the derivation level, because you were writing your own code. So you had to be sure that everything, the hidden neurons are really getting everything. And at that stage when we were doing it, we had to do it manually also, check computationally also whether the same results are coming or not, right? Which definitely improves your understanding, but at the same time slows you down, right? But today, because of the deep learning frameworks and their auto differentiation, you don't have to bother. If I can think of an architecture in my mind, okay, I think this architecture will work. Later on, I can do the derivation of how gradients are flowing. But the auto differentiation will build up the network and will do the differentiation for me. So that is one of the advancements that has happened. That is something which is very helpful in making the things work, making it fast. So, and that is what we can even see in terms of innovations, that the way they are happening. Because I can think of an architecture, I can think of a loss function, and I can do the things. I can see what results are happening, and then I can do the analysis if it is useful.
but you have seen how TensorFlow 1.x, any version of it, having that influence in terms of building a model or in terms of features also, because until then I think probably none of the frameworks had such an flexibility of giving a developer such an use of hardware acceleration on the one side plus the ease of writing the software. But what was those differences that you saw when you saw the documentation, or else when you started writing a book on TensorFlow 2.0 and beyond? And what's the difference that is still was not being debugged or not being improvised in 1.x?
Okay. So what I would say is when I started writing my first book, most of the people were still using TensorFlow 0.x, right? And my book was on TensorFlow 1.x. So obviously documentation was not that up to date. Documentation always is late, right? And you do not even have many people using the whole concept. So starting from 0.x to 1.x, things were much easier, much better. But you were still supposed to create the graph first. In terms of the things, like you had to first design the graph, that is the architecture of neural network separately, and then do the training and the session computation separately. With TensorFlow 2, that became kind of an eager execution, which was already there in PyTorch. So with the TensorFlow, that became 2.0, that became easier, first of all. Another thing was, when we really take up a real challenging problem, it is not just few thousand of data sets. It is a large amount of data set, probably in GB. So a thing which becomes very much necessary is distributed computing. This is something which again TensorFlow 2.0 manages by itself. So if you just tell it the clusters that you have, the TensorFlow 2.0 has modules which can take care of the distributed computing for you. So this is something which makes it, much easier to build the model and then to put it up to training, which otherwise would have taken a lot of time. Means if you go back and read the I guess it was ResNet, where they had to break it into two parallel GPUs, and they had to devise a way how to train that network, right? So all that thing must have taken so much time for them, which today you don't have to.
I just wanted to ask you this one question, because we talked a lot on how the frameworks have evolved, but like I just wanted to ask you this question on your first project which you actually tried doing? What were those technical constraints that you faced? Of course, you told 8086 was something which we used. Today when I see Pentium architecture, it's nowhere related to our present day PC, because even a simple i3 is much more scared in terms of clock, in terms of performance. Yeah, like, what were those technical constraints that you faced during the initial days, or probably your first project in the deep learning or the neural networks?
when I sta- when I started with the work with training neural networks again during my undergraduation, since it was optional, but I always wanted to do the practice and see how computers really learn. So I started up with making up a model which can learn few alphabets, A, B, C, D, E. Few alphabets. I was just starting with that, and I would say the problem which I used to have was memory. The RAM used to just go out after A and B. If I go to C, it would say I do not have sufficient space for the matrix multiplication. So this was a problem which we used to face at that stage. Today, then when I did my PhD, since I wanted to always use AI, and my PhD work was on erbium dot fiber amplifiers, basically optical amplifiers. And there the problem that arises is, you see, when you have to model a optical amplifier, there is something called as spontaneous emission. Okay, and we want to take that into account into the behavior of optical amplifiers. But doing those mathematical equations, they are basically second order differential equations and coupled differential equations, and there are n number of wavelengths flowing simultaneously, so we have to solve n number of differential equations, coupled differential equations simultaneously. That takes hell lot of time. Okay. An easier way would be if we could had a model which can do the whole thing for us. So I started up with, using a neural network to do a modeling of EDFA. Okay. So in that case, I was using at that time, I guess I had a Pentium machine with me. That was my first machine which I owned, I would say, right?
With the
And
DOS OS?
no, the Pentium had Windows, the
XP.
Pentium ones.
Okay, okay, yeah, yeah,
Yeah,
fine,
Windows
fine.
XP. Yes, Windows XP, right? It had Windows XP with it, right? And it was an assembled machine at that stage, but yeah, it was my own. And in that case, what was the problem was obviously the speed. So the whole model is learning overnight, 2 day night, third night, fourth night, fifth night, and within the nights I will get up and see how the model is going on. Is the loss really decreasing or not? Almost like parents see the child, whether the child is learning or not. It was that kind of feeling. Yeah.
Yeah, coming back to our deep learning world which we are facing now, it's the world of AI that we are moving more towards. AI is everywhere. But what's your view on AI alignment, which is now the next disruption which is coming in terms of ethics, in terms of problem statement, in terms of anything that we can think AI, this comes up. What's your view on AI alignment?
I would call more as AI divide. What I feel is what is happening is, you know, means you can see it even at the level that if you means just go and check up the research papers. Are the research papers coming from everywhere, or are there some limited areas, some limited countries, some limited, I would say, organizations, just few organizations which are having the most of the papers from. So I would say what is happening more is AI divide. There is haves and have nots, which is not right, because education and technology, and definitely AI, simply because it has so much possibility of creating disruption, should be democratized. We do talk about democratization of AI, but you know just having a knowledge that there is a field of AI will not give democratization. The data should be available to everyone. The computing resources is not available to everyone, so that definitely creates the divide. All right. So I would more call it as a AI divide, which is a big problem which is happening. And as a result of that, you see, we will have issues related to ethics in AI, how it is being used, who is controlling it. It will depend on that. As you might have seen in the previous face recognition, whether it should be used or not, again, a real ethical question, right? So these are the issues, and it will again depend who owns it. who controls it. So, it's really something which we will have to right now, keep our fingers crossed and hope that whoever has the knowledge and whoever has the control also has, sane mind to make sure that it is democratized.
Yeah, when you think of matrices that are measuring the performance of the model, or let it be the matrices which we are using in the neural network, how accurate are they and secure in terms of ethical interpretation?
I would say again, it depends upon the experience. First of all, like when you are starting up, you think of accuracy as the only means, right? But when you work with medical data, let us say, then you understand that accuracy is not the final thing. Or for example, when you're dealing up with imbalanced data, which is normally the case with the real data, accuracy is not everything. Accuracy actually can be very misleading. So there, the concepts of sensitivity for FPR things, these become more important. So there are large number of metrics which are available, and it is important for us to understand which metrics should be applied in which case, which comes with experience, with understanding of the problem, and so on.
Yeah, and also there is problem statement involved in medicine, there is problem statement involved in a quantum space, yet they are running on the
Yes.
same transistors which are running. Uh, People say that there is a requirement of new set of hardware as a transistor, let it be from the minute level for the quantum hardware. There is a huge speculation here and there. People have giving talks, theoretical quantum physicists have giving their own approximation for the material. But how influential is an hardware today in terms of getting these problem statements solved? Let it be proteinomics, genomics, your photonics also came into the picture, where you told that your neural networks were supposed to be trained, but it took a lot of time. And how are these data sets making that difference for these hardwares to work on? So what's your view on this?
I think data set is the fuel, which is definitely needed, right? And then secondly, the important part is computational resources. Both of them are necessarily needed. The only thing is, you see, how you are training. Like for example, even today, most of our machine learning models are static in nature. Once you train them, they remain that way for some time. What we need more is an online training system where not only are they giving the prediction, but at the same time also learning from the same prediction, which is more possible with reinforcement learning agents as compared to our existing machine learning frameworks that we have right now.
I just wanted to ask you this question because we talked a lot on hardware and the software. Of course, edge computing is in a verge where we are trying to make it the new computing standard for the industry, but frameworks are coming up. It's still a mature field. But like, I just wanted to ask you this one question about the system architecture. Do you really feel that the system architecture is robust enough to give a secure and a fair machine learning decision that we are desiring for? Let it be in terms of not involving AI alignment in any way, in terms of course, we saw how Elon Musk signed the Asilomar principle for the security, that he will never make a destructive machine. Like, what's your view on our system architecture? Is it really good enough to just make that one machine which can really give that fair and then precise decision? What's your view on this?
Well, if we talk about the present situation, I would say no. As simple as that, because it's as simple as saying that if I know, if I have a system, and if that system can go on internet, and I say no, my system is 100% secure, I'm a fool. It's exactly the same thing, right? You can take precautions, you can try and make sure that things do not go wrong, but there can always be some place, some way things can go wrong.
Yeah, I just wanted to ask you this question because you told it can't be secure, but can there be a data war tomorrow? Because it's a self constructed destruction that man is constructing it, but the man is also trying to destruct it and use it for something which is not that useful. Monte Carlo simulation was used in lot and lot of ways in physics, and approximating something as a physical model. But Monte Carlo simulation is also still used in the missiles. When you told about Pentium, I was still thinking, okay, Pentium might be old, but it's still used in the missile system to just make some decisions. You know, can AI really start a data war tomorrow?
It is very much possible. You see, the problem is not with the tool, the problem is with the user. Who is controlling it? So if it is in the hands of governments, chances are, because we see the governments are kind of, basically they survive with by creating threats. A politician survives by saying, oh, there is a threat to our country from another country. That country can be any XYZ country. That is how the politicians work. As you go through any history, that is how the kings survive, that is how the politicians survive, by creating unnecessary threats. So if AI is in the hand of governments, this is eventually going to happen. The problem is, then it is not in our control, because an AI, once it has come to the stage where it can create these kind of decisions, it might not be possible for us to find out where the problem is and resolve it out. Right. So, yes, data war is a possibility. And I guess that's why it becomes very important that no matter which field a person is, they should know what AI is and what it can do, so that everyone is aware about AI. Like, for example, I would say, in when we talk about the data privacy, right? So, this is something which I say we should be aware what data we are sharing, because that data is used, can be used against us. Right. So just saying, oh, I'm an open book, I don't have anything to hide, does not mean that you are doing something good. It simply means that you are still open to manipulation. And that manipulation can be a political manipulation, that manipulation can be an emotional manipulation. There's so many different levels where a person can be manipulated. So why do you give that, possibility to someone? Knowing your prediction, how you behave, knowing how you are going to, do things, lot things can happen. Like, for example, deep fakes, they were kind of disruptive at one stage, right? So it can be difficult, and it can definitely create a lot of wars unless we mature as, individuals. And it is important that everyone understands what AI is and what it can do, and how to make best use of it. It's just like, pressure cooker is useful, but it is very harmful as well. If you do not know how to use a pressure cooker, it is like having a bomb in each house. So the same goes with AI.
Yeah, when you told about emotions, of course, you had developed an edge based project just because your maternal uncle was not that well and he suffered from that, and you didn't want any person in this world to suffer. So you developed an edge based model using the Movidius stick. You also gave a, of course, you're a human being who has some emotions. Who, a human had an emotion for a person who is not related to you in a direct way, just like your mom or dad, your son, your husband, your any person that you are very closely connected with, as as we see as a family. He was not there in front of you for 24/7, but yet you had that feeling of, okay, he suffered from that, I don't want the world to suffer from it. But we are trying to build something as an AGI, but like we still don't know what's the actual plausibility of building that model, because we still haven't built the complete neural network architecture to actually demystify an human brain. So I just want to ask you this one question: how to build an AGI which can replicate in human being, and what are all those questions which an AGI can really answer tomorrow?
Okay, what I would say out here is, instead of jumping directly to AGI, the things that can be more useful to humans today, I guess that makes more sense. For example, our vision system, right? We have a part of our brain which is responsible for vision. If we can, instead of building up a complete AGI, if we can build up neuromorphic chips which can just replace that area of the brain, the work that is being done by that area of brain, they can just take that part and do it. The vocal system, there's so many people who cannot speak, right? So if we can start from there, that would be important. And in my opinion, the AGI will not come by a pure silicon system. Probably it will be a combination of humans and silicon, right? So machines coming into us, and we combining with that. And I guess that would be a better way of coexisting with the whole system altogether. So I guess that is where we should first of all go, finding out ways to deal with the situations where we can, even replace a small part of the brain with a corresponding neuromorphic chip for people who need them. They're blind who need eyes, but there are blind who have everything. Eye is there, but the brain part is not there. People in coma, right? So if we can do something for them, people in paralysis, if we can help them out using our understanding of neural networks, using our understanding of neuromorphic chips, that would be the greatest thing that we can do at this moment, I guess.
But what are those questions that it might answer if we
Oh, it can
build?
answer a lot, many questions for that matter. First of all, even, the questions about ourselves that we always ask. Who am I? Why am I? Philosophical questions that is there, I think. So what exactly is the thinking? Today, AI cannot think even if it appears to be thinking. So to question the concept of self, maybe we understand ourselves better when we build up those machines.
Thank you, ma'am. Thank you so much for this podcast. It's like 1 hour of session, which actually just told me like just go sleep with an utter satisfaction of interviewing Amita Kapoor. It's been a long time that I have been learning a lot from you, and I think probably meeting you virtually was something which which gave me utter satisfaction. Yes, I've completed my bucket list of doing a podcast with Amita Kapoor. Thank you so much for this wonderful podcast, ma'am.
Thank you, Vishwas, and all the best for your podcast journey. And I do hope you do a lot of good things in your life and learn a lot. All the
Yes, ma'am.
best.
Thank you, ma'am.